Hello and good morning everyone. Thank you for this opportunity to speak with you today and be part of this conference. My name is Matt Pipper and I'm the Global Industry Director for Utilities and AEC at Esri. For today's presentation, I'll be taking you through how the power of location is geo-enabling digital transformation within utility organisations. Now, Esri is the world leader in GIS and location intelligence, and as a global company, Esri spans many different industries. But what I truly appreciate about Esri is that even after 50 years, it still holds true its core value and the reason it was founded, which is to help solve some of the most difficult problems. Now, Esri provides solutions for managing many of the global issues being faced, things like climate control, unemployment, social equity, overpopulation, and of course, most recently, you would have seen the COVID-19 pandemic. But as you know, the challenges facing utilities are not independent of the issues that are being faced at a global scale. And while utilities have undergone more change in the last 10 years than they have in the last 100 years, the rate of this change is still increasing. And while we think that pace of change is fast now, it's actually plausible to imagine that this may be the slowest it's ever going to be. It's only going to get faster. So let's look a little bit deeper at some of the challenges that utilities are facing, on top of already the global events we just discussed. It is recognized that for many utilities, that the grid we have today won't meet the demands of the 21st century and beyond. The advancements in the technologies and the adoption of things like renewables, battery storage, microgrids, even IoT, is changing how customers are engaging with their utility providers, but it's also changing how the utilities operate and manage their grid. For many, managing this change is not going to happen overnight. There are many existing constraints that exist that utilities need to still address today. And for many, and from my experience, one of the biggest is most likely going to be aging infrastructure. Now, my background is I'm an electrical engineer, and I worked for almost 20 years at a very large power company in Australia. Now, being an engineer, I do like my numbers, so I thought I would share some of the key statistics that may be relevant for today's conversation. Let's start in the United States with the electric infrastructure as an example. Now, the electric infrastructure in the United States is an amazing network, and it is massive, with almost 7 million miles of transmission and distribution lines. However, most of the electric power lines in the US were built in the 1950s and the 1960s, and they have about a 50-year life expectancy. So while many of this has been replaced over the years, there is still more than 50% of the assets that are now more than 30 years old, and the cost to replace this grid is estimated to be around $5 trillion. Now let's take a look at water. On the water resources side, America has about 90,580 dams, and the average age of those is 56 years. And in 2016, 17% were found to have a high potential hazard assessment rate. On the water utility side, there's about 1.6 million miles of water and sewer pipes, and the average age of those pipes is 45 years. Now, the US also consumes about 42 billion gallons of drinking water every day. Now, however, there's about 240,000 water main breaks a year, which waste 2 trillion gallons of drinking water a year. That's 6 billion gallons a day. Now, to repair or just to keep pace with this asset replacement, it's estimated that's going to cost $1 trillion in the next 2 decades. Well, let's look at gas. The US has about 1.3 million miles of gas mains. The average age of the gas mains is about 35 years. However, more than 25% of these are more than 50 years old. Now, the average replacement program for these aging assets is about 5,600 miles of gas lines per year. And at that rate, it will take 230 years to replace it all. As you can see, utilities already have their work cut out just managing the existing infrastructure. But utilities are also seeing an increase not only in the frequency of natural disasters, but also in the severity. You can see here on the maps, just for the last 10 years of wildfires, earthquakes, hurricanes and tornadoes, that there's been significant events. In fact, 119 significant events in the past 10 years have exceeded $1 billion. That's costed approximately $807 billion. Now, these natural disasters, they put extreme pressures on existing assets and resources. And while many utilities are rethinking the way they plan, respond and restore during these events, they also have to put processes in place that allow them to respond and scale even better when required. Let's now look at another significant challenge. One of the main drivers for organisations at the moment is to achieve their renewable targets. Now, many countries and states have already committed to meeting their decarbonisation targets, something along the lines of they'd like to be carbon neutral by 2050. Now, a lot of countries and states have already committed to bring that forward and have targets as early as 2030 or 2035. These green energy alternatives are being enabled at the transmission level through wind and solar farms, through hydropower, biomass for the gas, but they're also being driven by customers, and the customers are making more and more environmentally friendly decisions by purchasing solar panels on their roof, by putting in battery storage, or even purchasing electric vehicles. This global energy transition is what a modern utility needs to transform to. However, it's a journey and it's not going to happen overnight. And while this future state is important to be planning for, as we just covered earlier, there's still so many other issues that utilities need to be embracing today and trying to solve. And finally, I think it's worth talking about is the COVID-19 pandemic. Now, 2020 has been a very interesting yet challenging year for many organisations. It's interesting in a way that our entire way of life changed almost overnight. But also challenging is the way that we've had to rapidly adjust to our new ways of working and deploy new processes and procedures. Now, for many, COVID-19 has been a catalyst. It's been a catalyst in accelerating many of the organisation's digital transformation programs. Now, this change has required better understanding and it's challenged the ways that we communicate and how we collaborate, but it's also highlighted many legacy processes, especially if you have any processes that involve paper. Now, I also believe that it's also making utilities rethink what can be done and when it needs to be done. Now, can you imagine if you had to plan on how to introduce a full remote project to take all of your workforce to work from home? Also establish processes and how to maintain social distances and to be able to check in, do health checks, perform contact tracing audits if required. Now, this work would be a multi-year and a multi-million-dollar project. However, this change was brought onto utilities and almost every organisation overnight. There was very little planning. And while some utilities were probably a little bit more mature in their digital transformation programs, nobody was prepared for this change. But what did become evident is how important location is in providing understanding, sharing that information, and gaining insights. So what is the role of GIS in all this? Well, if you think it's some of the amazing ways we've seen how the world is looking to overcome all these challenges we just went through, we have seen the emergence of the best in science and the best in technology, and we need our best problem-solving capabilities and technologies. And this is where we see the emergence and the importance that geography and GIS plays. GIS provides the context and the content in creating an understanding and a means to share and communicate information in a manner that is intuitive to people. People just naturally understand maps. It's almost ingrained in them now. It's one of the first things they'll turn to. Let me take you through an example about what I mean. Let me start with looking at some of the information sets that I'm hoping that you're all very familiar with. If you look at the screen, you can see things like asset data, customer connections, network designs, network switching, connectivity. And you probably agree that if you had all these data sets and the data was of good quality, that you could most likely operate your utility. These data sets that typically reside in your corporate OT or your IT systems, you have access to them, you control this data, and these data sets are pretty much what a traditional utility is familiar and comfortable with managing. But now let's look at what a modern utility is dealing with. We mentioned earlier, that it's a much larger array of data. They're all different information sources. Things like weather feeds, vehicle monitoring, traffic, battery storage, population growth, who's purchasing solar, who's buying electric vehicle cars, how are you managing your imagery and your LiDAR data. Now this data is different to the stuff of the traditional utility. It's unstructured, it's usually big data, both in volumes and at the velocity, but it's often not owned by the utility. I hope this makes sense, because this is one of the most important things I hope you understand, that as many of you know, to create relationships between data and information, you typically require some sort of unique or common identifier. This allows a referencing to build that relationships. But as I mentioned, this data, it's unstructured. There's no common key. And as you know, the way you join data is through this common key. So what does all this data have in common? Well, it's quite simple. Location. Location is the commonality. This is where the role of GIS comes in. GIS allows you to integrate all these data types and formats using location. And it doesn't really matter whether it's tabular or it's imagery, if it's CAD data, 3D, real-time, multi-dimensional. GIS provides that common reference system that creates the content and the context through the power of location. Now, when we discuss this application of location technology into a utility, we can look at it primarily as this concept of a system of systems. The first is the system of record. This is that authoritative source of truth for the information. Now, for a GIS, this is typically the information that relates to the network design, the connectivity, or the topology. Then we have this concept of a system of insights. This is the business intelligence and the analysis that is applied to information to assist in making better business decisions. And finally, there is a system of engagement, which is how all this information is shared and communicated with stakeholders both internally and to external parties in a timely and a controlled manner. Now, this capability allows for enhancing your organization's ability for what we call coordinated operations. So this is the same data that is used at a desktop. So if you've created a map on your desktop in planning or design, this can then be pushed, and it's the same information seen in the customer service team to manage connections. It's also the same data available in field for data collection or markups. This data is secure. It can be controlled based upon your role. So if you're an editor, you get to edit. If you're only a viewer, you can do viewing. And it's provided in a timely manner. Now, this is critical because this greatly improves your overall operations. It can enhance your safety. It's an enabler for improving data quality, but it also critically reduces this amount of information latency which many utilities suffer from. So why is this all important? Well, we are now living in a time when everything is connected. However, for many organizations, they're still constrained by bespoke solutions that are unable to scale or have significant customized integrations. Now, these customized integrations are limiting the ability to move forward, and many organizations are not reaching their strategic vision of a modern utility. But it's also significantly increasing this concept of your overall technical debt. A modern GIS is built from having what we call a geospatial infrastructure. Now, this provides the platform to interconnect everything from your individuals to the teams, to departments, to organizations, to communities, to help you reach your digital transformation strategic objectives. Now, utilities are on a transformation journey, but it's important to remember that it is a journey, and one that requires this strategic vision and the supporting infrastructure. So let me demonstrate how GIS is interconnecting utilities as they evolve from being a smart grid to being a smart infrastructure on this digital transformation journey. Let's start with looking at an electric network. We discussed how it models and manages from generation to customer, but it also manages all the emerging technologies like DERs and microgrids. Next, if we continue to the next scenario and we look at a gas utility, we see the same complete network from generation, beginning at the wellhead, all the way down to the customer. And just like the electric grid, we also see the introduction of renewable assets like biomethane or carbon capture storage. Now if we look at the telecom network, we can begin to visualize the relationship that exists for the critical backbone of the communications network and how it overlays the telecom and cable networks with other infrastructure assets and their customers. If you look at the bottom of the screen, you can see how we're modeling the more traditional fiber networks on the power lines with the drops to the customers, but we're also able to represent how customers are moving to fixed wireless options as well. For a water utility, GIS is becoming a pillar to smart water. We see the creation of modern intelligent water systems from the source, through production, to consumption, to the customer. A modern GIS allows the visualization across domains. It visualizes the water resources with the water infrastructure and the wastewater and the stormwater. Now if you bring all these together, you can see that everything is connected through location. And we can connect your OT and your IT, we can bring all your real-time data and we can bring it together into the control room. Now this is that IT-OT convergence that many utilities are trying to strive for. This is that integration with some of your other key enterprise systems like an ADMS. But what this is doing, it's bringing all that information together and putting it in the hands of the decision makers. This is now bringing in things like real-time weather, traffic, the ability to actually manage and control your network in context of what is actually happening on the network in comparison to all of the asset information systems, the customer systems, and bringing it all together. This is a powerful differentiator on the value of what a modern GIS provides. Well, that is all we have time for today. I'd like to thank everybody for listening. Now, if you have any questions, please feel free to reach out to myself or any of my fellow Esri colleagues. I hope you enjoy the rest of the conference and have a great day. Thank you very much.